Hello. Today I will talk about reversed phase chromatography. My title is Separation of the 5 Penicillins by Reversed Phase High Performance Liquid Chromatography. These are the structures of the 5 penicillins, which are Amoxicillin, Ampicillin, Penicillin G, Cloxacillin and Dicloxacillin. This is the chromatogram of the 5 penicillins. From the chromatogram, we can know that the first peak is Amoxicillin, and the second peak is Ampicillin, and the following peak are Penicillin G, Cloxacillin, and Dicloxacillin. You can refer to the number to know which peak refer to which substance. From the peak produced by the substances, we can clearly know the elution order of the substances. From the chromatogram showing in the previous slide, we can know that Amoxicillin is the first to be eluted out, followed by Ampicillin, Penicillin G, Cloxacillin, and the last to be eluted out is Dicloxacillin. Do you know why does this happen? I will now explain on the principle and mechanism of the reversed phase chromatography. In reversed phase chromatography, the stationary phase is hydrophobic, and the mobile phase is a more polar aqueous solution. The main separation mechanism in reverse phase chromatography is hydrophobic interaction. From the diagram above, we can see that substances B, which is less polar analyte, interact with stationary phase, while substances A, which is more polar analyte, do not interact with the stationary phase. Nonpolar analytes are therefore retained strongly, while more polar analytes eluted earlier. In general, polarity is the primary characteristics of compounds that can be used to create reversed phase HPLC separations in a mixture. All components in a mixture have a unique behavioral characteristic related to their molecular structure. They can be described as being polar or nonpolar. For effective chromatographic separation system, making the mobile phase and the stationary phase with different polarities creates a competition for the different sample compounds. Since the compounds in the sample have different polarities, compounds which have the same polarity as the stationary phase will slow down because they are attracted to the particles. Any compounds that have the same polarity as the moving mobile phase will move along at a faster speed. The order of polarity is actually the same with the order of elution. The most polar compound, which is the amoxicillin, will be eluted out first, while the least polar compound will retain longer. Why is amoxicillin the most polar compound? Amoxicillin is the most polar compound, and eluted out first because of the presence of polar group NH2 in the amide side chain, and hydroxyl group at para position of benzene ring. Ampicillin is eluted out secondly, then followed by Penicillin G, because Ampicillin is more polar than Penicillin G. This is because Ampicillin has an extrapolar group NH2 in the amide side chain. Dicloxacillin is the least polar substance and eluted out lastly, compared to cloxacillin and other 3 penicillins. This is due to the presence of 2 nonpolar Cl groups attached to the ortho position of benzene ring in dicloxacillin, while cloxacillin has only 1 Cl group attached to the ortho position of benzene ring. So, cloxacillin is more polar than dicloxacillin. So the most polar substance will be eluted out first, while the least polar substance will be eluted out last. In conclusion, in reversed phase HPLC, the stationary phase is hydrophobic, and the mobile phase is a more polar aqueous solution. The stationary phase is typically made of silica derivative with reagents to form a more or less hydrophobic surface on the silica particle. On the other hand, the mobile phase normally consists of mixtures of water and 1 or more organic solvents that must be miscible with water. Lastly, one of the most important thing to remember in reversed phase chromatography is that Non-polar substance will retain strongly, while more polar substance will be eluted out earlier.